Test.
1, 2, 3. Test, test.
Excellent. All right. I'll start it like we do our podcast. Hey, everybody. This is Greg with TheBrothersWISP. Thank you. Drop a beat. Timing is everything, as Dave would say. Yeah, so this is going to be routing best practices. So it's kind of loose. In AMA, they make us say there's a topic, but there's really no topic. So it's going to be kind of routing related. Normally what we do when we start the podcast is I say, I'm from Texas, the motherland. Anybody else? All right. Rest of you, get out right now. Then we've got Miller from Virginia.
Howdy. How you doing? I'm Dave from LA.
I'm Thomas from Middle Europe, Slovakia.
I'm Justin from Indiana.
Excellent, excellent. All right, so a couple of notes for this one. MikroTik related questions only, right? We're at the mum, so keep it there. Ask us non-internal questions. So don't ask me when a feature will be released. If you ask us about products that are unreleased or things like that, I will seamlessly make up an answer, right? So just be prepared for that.
And Giannis may or may not disappear you, so be wary.
Yeah, for sure. This is Texas. We got a lot of land. We can do things. Routing-ish related questions would be good. Please participate. I literally have prepared nothing. So if you guys don't ask us questions, this is going to be really boring. Dave. Yeah, Dave's gonna. He's got a little number put together for you guys. He'll do. And at the end of all this, find us, introduce yourself. We do the podcast. Subscribe to the podcast. Listen. It's network-ish related. Sometimes we go on tangents that really you never quite know where they're going to end up. We also have a patron-only Slack, so patreon.com/TheBrothersWISP. Join in there. It's a great ecosystem where you can ask any kind of question, and it's people way smarter than me. As Nick would say, I'm definitely the dumbest guy in that room, so there's a lot of really good discourse in there. Anyway, let's start it off. Looking at the crowd, questions, anything, MikroTik related, routing related. Are you going to make me come up with stuff off the cuff? Anybody? Any
Who
questions?
here runs MPLS on their network? Okay. I'll ask you, why? Reason.
So we can run VPLS tunnels to /32s to our customers without having to route public IPs all the way through.
So you're doing, so it's basically it's layer 2, right? So from the tower, VPLS allows you to do a layer 2 connection back to some other endpoint, and you're doing the /32s. Why not do PPPoE out on the edge? You could do /32s that way.
I think it just added a layer of complexity. I knew MPLS already. So.
Oh. So you had some familiarity with it. Gotcha. So I know there's some people who will extol the virtues of PPPoE, kind of hover my hand over this area over here. I'm a big fan of it because not only can you hand out that /32, but you can also seamlessly add other things like rate limits for that customer, right? From your NMS or your CMS, right? It can hand all that information down.
Also, why I particularly like to sing praises about PPPO is that it natively deals with load balancing and failover, which it just deals with it natively. It saves you a headache of having to deal with it, at any other layers. And address saving, it's super easy to route publics around the network, and
Yeah. So what else? You don't have to.
You don't have to have layer 2 to get your PPPoE concentrators. I mean, you got to go to each tower.
Mhm.
That's a nightmare.
yeah, well, it just depends. It just depends on how you architect your network and what you want to do. So we actually, for my network that I used to run, we actually first started with, when we migrated, like back in the day when we started doing PPPoE, we had it one central concentrator and then VLANs, which of course then we migrated to fully routed and MPLS VPLS, and we had two central concentrators, which all the VPLS tunnels from around the network converged onto tunnel concentrators, and then two PPPoE access concentrators. And then finally we actually migrated to PPPoE server per tower. And that was actually, well, so for me, it's not a nightmare because as long as you have radius and as long as you have a way to maintain all of those individual servers, to make a long story short, it depends on what topology you choose, what architecture you choose, how do you do your authentication to your network, how do you do RAID limiting, how do you hand out addresses, and how do you address to the customer? Do you route subnets, or do you just have business customers that require actually having subnets routed to them, or do you just have home customers, which maybe 1 out of 10 will even want a public address? It's a complicated answer because it just depends on what you are trying to do, what your topology is like, and yeah.
I'm going to pick on Adair back here. Yeah. You're running MPLS on your network, right? Why? Okay.
Yeah. So Adair is saying that it's less complex. You think, in your opinion, it feels more comfortable. All right. Well, I mean, that's still layers of abstraction, right? You have to do MPLS, and then you're doing a VPLS tunnel, and that's going back to a concentration point. So theoretically, if you have problems with that one concentrator, that all that stuff's coming back to, you're going to have issues, right? Or with a PPPoE distributing it out, if you have issues with one PPPoE server at a tower, only that single tower is affected, right? Not everybody else. So it kind of distributes the blast radius of an issue, theoretically.
That also depends, because actually when you are doing PPPoE at the tower, there is nothing stopping you from having a VPLS tunnel to another tower that also has PPPoE concentrator. And this is the nice thing that I mentioned about PPPoE, that it natively handles load balancing and failover. So you literally have to do nothing and you automatically get failover. But so how that works, for anybody that doesn't know, it's basically based on latency. The client broadcasts a PADI, PPPoE active discovery initiation request, and the first access concentrator that responds handles that connection. So if the local tower is up, the local tower will always process those PPPoE incoming sessions. If the local tower dies for some reason and you have a VPLS tunnel to a different tower that has a PPPoE concentrator, normally that one wouldn't get connections from the second tower, but if the one at the particular tower dies, it automatically just fails over without doing anything to the second tower, simply because the other tower is higher latency, but PPPoE takes care of all of that natively. And you can do some really nice tricks and playful things with PPPoE like that, which is why I personally like it.
Yeah, and I think that speaks to MikroTik and its power, right? Wildly successful network, very stable. Wildly successful network, very stable, right? You can take different approaches, and this allows you to do it, right? And even then, Thomas was saying you can do a hybrid of the two, if you wanted to, which I think is cool. That's cool. Well, in the networking world, I know every additional layer you add is another layer of complexity, another potential for bugs, or if you're rolling in a new engineer, another learning curve, a new thing you have to troubleshoot. So, right, it's where's your comfort level, I think sometimes too, right? And then I've also seen guys that have networks that are basically 2 towers, and they have full-blown MPLS, VPLS, and it's like, you sure about that? You're driving your Ferrari to the end of your driveway to get the mail? I don't know that you necessarily need to go that deep down the hole yet. But then again, if you start that direction, it's easier than trying to migrate later, once things is, I mean, you guys are Wisps, right, most of you? So does your network grow in a single linear fashion? No, it never does, right? It kind of spiders out, and, I can hop from here to there. So sometimes having that design in mind beforehand is a good idea. Any other topics?
Oh, yes.
Say if we're running a PPOE server on each tower, and say some towers we got like one person that needs a public IP address to the PPOE, other towers we may have 10 or more. We don't have enough publics to assign a subnet per tower. How would we get around that?
Yeah, that's the beauty part of PPOE.
So That's exactly the beauty of PPPoE. It's all just /32s. You literally don't deal with subnets. Everything is a single IP address from the point of PPPoE. So what you do is you assign a customer a single /32. Your access concentrator itself can have a private IP. It doesn't matter. And then inside OSPF, or if you are running BGP between towers, doesn't matter. Inside of your dynamic routing protocol, you just redistribute that address from the tunnel. And the nice thing is, if that PPPoE tunnel reroutes to the other tower, if you have that hybrid multi-tower, or reroutes to a different access concentrator, your routing protocol will take care of, redistributing the flow to the proper place in the network. So basically, you don't deal with subnets at all. It's all just single individual IPs, no waste anywhere, and
Yeah, it's kind of crazy. Imagine you only have a /24 for your whole network public-wise. It doesn't matter if it's coming off East Tower, West Tower. It's really just each individual person's a /32 into the dynamic routing protocol, and it goes across your network.
That's something we were looking at, but we were told to be concerned is if you advertise a /32 to that one tower, well, that PPOE connection goes up and down. That's going to advertise an internet.
Yeah. Well, if you're doing it via BGP, it's a more graceful protocol. So it's more resilient to flapping, right? And so it will kind of more gracefully do that. Now, if you're doing it in OSPF and it's area 0 and you've got all these towers in area 0, that's going to cause a lot of convergence issues, right? So whenever the table changes, everybody else has to recompute inside that same area, and that's going to cause issues. So,
And a lot of things you hear these days are left over from the router world when they had 4 megs of RAM. So we now have all these fast processors. We have all this memory, so we can have larger routing tables and we can compute them quicker. So a lot of stuff like this that you hear, it is relevant, but not like it used to be.
Is there a way for the PPOE server to advertise that IP for us?
As soon as it's inserted in the routing table, it's being advertised. So.
One thing which I really recommend talking about PPPoE and scaling and compute power, and surprisingly little people do it, make sure you actually select who is DR and BDR for each segment. So Greg said that everybody has to recompute, but only the DRs actually do the compute.
I lied.
Right? Greg. Well, yes, there's always an asterisk, but yeah. So usually in most situations, only the DRs and the BDRs do the topology spanning tree calculation, right? Shortest path tree calculation. So make sure you actually don't leave that to auto. If you just do nothing, a DR and BDR is auto-magically, there are rules, but basically it's auto-magically selected across all the layer 2 segment, right? So what you can actually do, if it's called priority. So each OSPF interface has a priority, which is very different from path cost. Priority just controls who gets to be DR and BDR on the segment. If you set it to 0, the router that has 0 as a priority will never become a DR or a BDR. So I would really, if you have like a link where you have some really 400 megahertz all boards, and you have a single like 4011 or 750 GR3 or something there, make sure that's the BDR and the DR. It will save you a lot of OSPF trouble and flaps and all of that. And it's a really useful little trick. Doesn't cost you anything. Just set the slow processors to 0, or just set the ones that have better processors to be DR and BDR. And usually that can actually solve a lot of issues with OSPF scaling.
Gotcha. So he was saying that in his smaller network, you guys usually just do a one-to-one NAT at the border for people that want public IPs. Yeah. Gotcha. So he's also saying that he'll do an EOIP back to, I guess, your border router where the IP space lives. And so EOIP, you can do layer 2, right? So you can bridge across that, kind of like an MPLS, VPLS, just this is more a MikroTik proprietary tunnel that will do it and allow you to add bridges on there.
Yeah, and do you run into, the only problem I've ever had with that isn't a technical problem, it's explaining what you're doing to the local IT shop when they come out and set up the customer's router. They're used to having the IP on the customer router, then you got to go through a whole spiel of what the one NAT is, and yes, yeah. So, yep.
So the EOIP, it's a great tool, but you also have to be careful how you use it, because EOIP will bring fragmentation and packet assembly and reassembly into your network, which can be an issue of its own. So just make sure if you are using a technology such as EOIP, you actually understand what is happening to the packets on the backend, because many times EOIP is super easy to turn on, right? You just click a couple of buttons and it's done. But what people usually don't realize is that it has consequences, right? Because it's a tunneling protocol, which means there is tunneling overhead. And if you don't have MTUs correctly set up across the network and you try to basically run a 1500 MTU inside of the EOIP tunnel, you will suddenly introduce fragmentation and assembly and reassembly for every single packet going across the network. And that has issues of its own. So just be careful, because everything has some kind of a impact on what you are doing, including EOIP, which many times can be a detrimental impact.
Yeah, so there's always a trade-off, right? One way or the other.
UIP also is a stateless protocol. It doesn't check to see if the other end's actually there or not. When it says R for running, it's actually running on that interface. It's not the link going.
They added a keep alive feature
Yeah.
not so long ago, so that it actually will communicate between each other, and if one side has a problem, it'll bring both sides down. So that's true. That used to be a problem. They've subsequently fixed that. I can't remember when. I'm not good at remembering those sorts of things, but I know it is.
If you terminate an Ethernet over IP tunnel into a bridge, it'll take the MTU from the Ethernet over IP tunnel. If you terminate a Ethernet over IP interface into a bridge, it'll take the MTU from that and cause your bridge to have a lower MTU and cause you problems.
Really, from experience, somebody.
And that's an automatic thing, right? So you may not even notice it at first. Is that the idea? Yeah, that could be problematic.
So I own a medium-sized Wisp, and we use OSPF, but it occurred to me that a lot of people attending may not even be anywhere as close to what you guys are talking about. Maybe let's go back to a lot earlier and a lot not as evolved, and say people that are currently running, bridge networks or something that are maybe just starting to get into routing and it's very new for them. What's some advice that you guys would give in terms of best practices and things to make the transition from bridge to routed a little bit more simple to understand, and things that you should do from the onset so that they're not a big pain
Gotcha. So just say it aloud so that the microphone over there can hear it and everything. It's you're a bridge network and you're looking to move to routing. So maybe one, I would say, what's the motivation to do that, right? So why would you even bother going from bridge to routed? What are the advantages there? What are some pitfalls of maybe not doing it? And even then, what are some of the pitfalls you might see if you do it, right? So one, I think sometimes is just convincing people, because I've seen some very big bridge networks and somehow or another they work, and maybe they haven't been bitten one way or the other, and those people are harder to convince. What would you guys say? I know Thomas. We'll save Thomas for last because he's going to have a lot to say.
I'll say we did a presentation session 2-3 weeks ago at Wisp America on bridge to routed. So I think the slides are probably posted. If not, I'll post a link on my blog to them, because it was all about bridge to routed. So I'll let these guys talk. We did 45 minutes on bridge to routed, lots from 3 different folks. So
I can't believe Justin just said RTFM. That's what I heard.
Anybody got any VoIP questions?
No, I think, all right.
Just give me a little candy, something.
Let me throw you a bone. I'm going to take a stab at it. So why would you go routed? Say, you guys are Wisps, you have towers, or say you have POPs in different places. Say you've got a tower that's orphaned off over here, and all of a sudden your network's shaped like a triangle, and you want to add redundancy in between those, right? If you just add another link on layer 2, you can create loops, right? You have to trust STP to do all that stuff, so it becomes more problematic. And STP wants to generally, there's modifications to this, but generally it wants to shut a link down and then just use one other one, right? Whereas if you're doing routing, it can actually do some load balancing. If you have failure, it can reroute fairly efficiently. Broadcast storms, you have to worry about those on layer 2 networks, right? Multicast storms. Somebody plugs their router in backwards and it's a rogue DHCP network router on your net. Yeah, see? It's happened to everybody. Like in Disher's presentation when he said don't leave allowed DNS connections in. I think we've all done that at some point or another. I'm not ashamed to admit it.
You can also aggregate links together using equal cost multipath with OSPF, which is a good way of getting a little bit more out of 2 links instead of going to a much larger link.
So what you're talking about there is 2 towers, and now you have 2 sets of radios going in between them, right?
Yep.
And you can allow just 2 routed ports to load balance across those. Right, what would be an alternative? If you're trying to do it layer 2, you could try and do LACP across that, but it was never really designed to go across a wireless link.
Or Ethernet over IP tunnels and gag those together.
Yeah.
Friends don't let friends do spanning tree either.
Thomas is a big proponent of spanning tree. I like it too. It's always been kind to me. Not always.
I knew that I'd get it.
So spanning tree, like every tool, has its uses, right? And I feel spanning tree is one of those things that gets a really bad rep from people simply because they use it for things it was not designed to be used. And so I just want to say I actually love spanning tree when it's used correctly in the way it's supposed to be used. It's a wonderful tool in your toolkit. Spanning tree is not bad by itself. Using spanning tree for things which it should not be used is not quite the best idea.
Wasn't spanning tree originally designed to be like 7 switches deep at max, something like that?
Yeah.
Yeah. So
Originally, yeah.
Yeah. So if your network gets really big and sprawling, I mean, honestly, it was never designed for that sort of thing.
Oh, rapid spanning tree got away with that limit, but
So what are the advantages of moving to a routed network, Thomas?
I think the best and easiest way to surmise it is just growth. When you are going to grow, it's going to be you will get to a point where your network just collapses. That point might come sooner or later for different people, but it will come to that point. Fully bridged networks just don't scale. That's it. So if you are planning on your business growing, and if you actually want to grow your business, then you want to do everything for your network to do well and to be ready to scale and to be ready to grow.
Yeah.
And bridged networks just aren't that. So as long as you want your network to grow, bridged networks are not the right way to grow your network.
Yeah. I also like to think too, when you break up layer 2 domains like that, if a tower is a routed domain, you limit the blast radius. So if something goes catastrophically wrong, it's only going to affect there. Say you've got a big bridge network and you start getting a loop and your whole network goes down. How are you going to troubleshoot that? You know?
The number one thing I want to say is start with an IP plan. It took me many years to come up with a cookie cutter plan that works for every network, and we finally have one that we roll out to clients. But no matter what you do, start with an IP plan. Plan for growth. Plan for what you're doing now, and because that's the number one thing I see is I go into these networks and they've gone from bridge to routed, and they didn't plan for the growth. They're saying, yeah, they just have these random IPs here, there, and everywhere, and it just becomes a mess.
Yeah. Something else.
If we are talking about growth and planning, have a frequency plan. That's
Yeah. So something else, people said, I think when you're going to start the conversion, start in the lab, right? Nick and John both, and we did like a series of tips videos where people just got on and told us, hey, here's like 5 things I think are super important for every WISP, whether you're new or old or whatever. And John and Nick both said, put it in the lab, build it, and then once it's in there and it's built and you got it working, break it. Break it in unexpected ways, because that's what's going to happen in the field. And you don't want to try and figure it out at 3 in the morning, right? You want to do it when you got it on your bench. I think, 2, for me, if you're going to go routed, don't try and start in the core. Scoot all the way out to your least utilized tower and convert him to routed first, right? And then let it sit for a while, let it marinate, right? Put it in the fridge for a couple days, pull it out, you know? That's going to help you work out the kinks in as least impacting way you can, and then start kind of working array around the periphery and then come back towards the core. At least that's been the most successful way I've done it. Trying to wholesale do stuff is always a terrible idea. Trying to convert a whole network over a weekend, right? Piecemeal it. Take your time. All right, so the question here was, what's the advantage of switching from just a pure layer 2 over to a VPLS infrastructure? And you also mentioned there's mitigation techniques in hardware, right? Like DHCP snooping, which will prevent rogues. You have broadcast storm control. You have source guard. Horizon values. Yeah. Well, so what you're saying is very true. The layer 2 is layer 2, right? There's going to be inherent dangers and risks associated with it, whether you're doing pure switching or you're doing tunneling technique like VPLS. I think the mitigation stuff is the same. What we were just talking about before is pure routing, which means there's no layer 2 except for in between individual links, right? So it really mitigates that to that individual link as opposed to an entire swath of a network. Justin has some.
And it depends on if you're an access network or if you're a transport network. You can have the different layers and you can run, an all bridge transport network because you may be just a layer 1 transport. But when you start talking access of the customers, you're going to have to step it up a little.
I think a large part of it also comes back to scaling. Scaling those technologies like DHCP snooping, source guard, and just doing everything everywhere on layer 2 and properly securing it, it's painful. It's you can do it, sure, but is that the right approach? That's the question, right? What is the better approach that will yield better results at less overhead and management from a technical point, messing with all the configurations constantly. And yeah, sure, we could debate like, how can I make a layer 2 network work, or can I make a layer 2 network work? Certainly, yeah, we can. There is technologies there that deal with this. The question is that the right approach? Which, yeah. And as far as VPLS versus bridged, because it is kind of the same concept, but the point is that VPLS gives you full control. You decide what you want to bridge, what you don't want to bridge, where you want those tunnels to start and go and end. And with a pure bridge network, you have zero control. Everything is one layer 2, right? Whereas with VPLS, you gain the power of layer 2, and you can actually even sell that as a service to your customers. Many people do this, sell private VPNs and private links across a network, right? Because that's what VPLS can make happen for you. So you gain additional tools, but you don't have the disadvantages of one huge, bridge network. So you gain control, you get additional services you can sell, you gain additional advantages in having a routed network, of course, with MPLS, VPLS on top. And so it's similar in some ways, but completely different in others, right?
I'm sorry, Wilson, are we boring you? Sorry? No. No, but one other thing I just wanted to throw in really quick while you're talking about layer 2 kind of mitigation techniques. MikroTik is starting to implement those in their switches, and better part is they're implementing it in hardware on their CRS 300 series stuff. So, I mean, you can turn on DHCP snooping in a lot of their switches, but you'll see the little H in the bridge stuff go away. On the CRS 300 stuff, you can turn on DHCP snooping and the H stays on, which means it's hardware. So it's going through the ASICs, which means you're going to get more efficient switching through there, which is super cool.
Real quick, do you know if MikroTik has implemented fast path through VPLS tunnels yet?
I'm going to source the crowd here. Anybody have
MPLS itself is fast-pathed, and a VPLS, so it depends if you are talking on a transit router, so a label switch router, or a label edge router, right? On the layers, label edge routers, it's not fast-pathed. On the LSRs, it is fast-pathed.
This guy over here.
IPv6 dual stack, you guys running it, and was it, how big of a pain was it?
All right, so intro to IPv6 dual stack. That was the question, right?
Kevin Myers at IP Architects, his stub area 51 has an awesome tutorial for dual stacking IPv6. I've sent it to customers and they're like, okay, we're dual stacked. It goes back to the IP plan. You know, whether you subscribe to the theory of I'm going to put a 40/40 at every tower, I'm going to do a /48 to every tower, I'm going to give my customer a 56, I'm going to give my customer 6. That's the hard part. Dual stacking it, and speaking of dual stack, anybody who's running IPv6, have you updated your routers, or are you going to before Monday? You should. Yeah, does everybody know what we're talking about with the IPv6 bugs?
Yeah.
Okay.
Yeah. Thomas has a really in-depth one on there.
But it's really, from my perspective, it's not really that hard once you have the IP plan.
I think a large part of it is people consider IPv6 scary. It is considered scary, but it is different. I'm not saying it's the same. There is a bit of a learning curve, but once you learn it, you realize it's still IP. It's not a different protocol. It's still IP. It's just a little bit different. So I think just forget about any scary, anything that prevents you, and just learn it. It's not hard. It's not anything super foreign. It's a little bit different, sure, but once you actually get into it, you pick it up real fast, and it's just an IP protocol.
Yeah, chuck it in the lab, right?
And the thing I tell everybody, think in terms of subnets, not IPs. When you think IPv6, throw away the notion of, oh man, this is lots and lots of IPs, I got to conserve them. No, think in terms of subnets. Your subnets are your new IPs.
Yeah, the way I look at it is I'll be dead before I have to deal with it, so not a big deal. Well, I mean, I'm burning it down, dude. It's like I got 4 years max on me, so.
The MAC address exhaustion is coming real soon. You gonna be around for that one?
I'll think about it.
All right.
Let's see. Play it by ear. Also,
Voip question, Ty? I'm trying to help you.
one last thing for IPv6 I wanted to say is make sure your upstream will actually hand you an IPv6 connection. If they won't, what's the point to talk about it?
From a provider standpoint, what can wireless ISPs do to best benefit VoIP performance? Like, we don't provide it,
Yeah.
but we know we have customers that use it, and I don't want to be in the way of that, and we definitely don't want to drive them to another provider because of that.
So Ty's question was, what can Wisps do to provide good VoIP service, right? And really, that's going to depend on your network, because VoIP is a real-time protocol, and your network's got to be pretty damn solid. You can't oversubscribe any of your links. So, yeah, I guess one way to say it is a true test to see how good your Wisp is set up is run VoIP. But I wouldn't run it to customers yet, but you really do have to monitor your links and make sure that you have good signal strengths, you have a lot of throughput, and your customers' networks as well, because 90% of VoIP problems happen at the customer's network, at their point of exit. So that's also the other part. You see, VoIP is so sensitive because it's real time. So you have to make sure that the packets get through all the way from end to end. I mean, naturally, you're going to want to have like a PBX, or a Wisp would want to have a PBX at their, right next to their core router, where everything comes back to. But basically, that's just the bottom line answer. You got to have a good network.
What if they test their network and it's not clean? I mean, what are some best practices you would say?
You mean the customer's network or the Wisp?
In the Wisp, right? Inside your network, you're not getting the performance you expect. I mean, how would you troubleshoot that?
That's
what would you
guys. That's what you guys just spoke about, like how to make sure everything in your Wisp is running properly, and you don't have any anomalies, and you're using STP the right way, and you have your failover set up. But your network's got to be good, and that's really what I primarily focus on when I sign up a customer. Is I'll go in and do prioritization in their router. I'll test to see how much bandwidth they have. Obviously, test the links to and from the customer, from the VoIP server to the customer's network and back, because it's obviously doing a round trip. So I'd say do that, and just with VoIP, you really have to set up everything right, because it's like a house of cards. You get one little problem, everything collapses. And by the way, I don't know why, but I've heard some people trying to tunnel VoIP traffic through a VPN, through like SSTP. Very bad idea, okay? Because the second you retransmit VoIP, okay, packets are out of order. And by default, a PBX will drop any packet that's out of order. Because in real life, you can't reorder something that's real time. It just wouldn't make sense. You could have a really big jitter buffer, but the bigger the jitter buffer you get, the more overall latency you're going to introduce. So with VoIP, it's really get it right the first time. Set up your network correctly the first time, because VoIP will very quickly teach you that you have a problem and you may or may not know how to fix it. And God, try explaining that to a customer that has a bad network, because I'm not a Wisp, but I have customers that use whatever internet connection they have. And if there's a bad route somewhere along the internet, which happens occasionally, level 3, the customer's like, our VoIP calls are bad. And I'm like, all right, well, let's do a trace route and see what's happening. Okay, I see there's a problem over at level 3 in somewhere between LA and New York, right? Well, since then we've actually...
route's not always indicative, right? So when a router's under duress, ICMP is usually one of the first things that drops. So how do you test like jitter and stuff like that, or out of order packets? I mean, what are you looking at to see that stuff?
You got to start with the basics, because a customer, the real way to test VoIP is with VoIP, unfortunately. There are these online tests that you could do that'll test like RTP traffic or SIP traffic, and it uses your web browser. But the problem with that is just it's going to their server. It's not going to my server. So we're testing a connection that's going somewhere else. I don't want to do that. I want to test it to me. So eventually, yes, we're going to implement something on the web that can set that up, where they could do a test using RTP and SIP through HTTP. But again, try to start with the basics. Try to start with a ping. It'll just tell you enough of what you need to know. Then go a little further, do a trace route, and then take a look at their router, see how much utilization is going on there, and really set expectations with a customer. Because again, VoIP, try explaining to a customer that their connection has a problem, and they're like, but I can browse the internet just fine. So you really have to walk that tight line and kind of try to educate the customer, and at best just fix it, because some customers just aren't going to care what the problem is. They just want it fixed. So another thing you could do is make sure your server is really close to the customer route-wise. That's another thing, and we've put servers all over America now to make sure we don't go across any crazy amount of hops. But yeah, but I hope that answered your question.
It still makes me think about like ping ICMP. It's like a protocol that's older than I am, and it's still like our go-to.
I'm a real big fan of smoke ping, because when there's smoke, there's usually a fire, and that's usually a customer that's going to be calling you. It's a great indicator of interference, and also of Ethernet port flaps and stuff like that.
I mean, you can also, so I've seen Miller's graphs before. Yeah, he'll show you his graphs too. But he's got some transit links that he buys. I don't remember who they are. Anyway, sometimes they'll take an alternate path, right, like a protected path, and you can see very clearly on his smoke ping when it just took the protected path.
Comcast.
And it's, yeah, there you go. And it's trash, and then you can see immediately when they repaired the link and it came back. If it comes back, right?
And that's the other thing. If you're going to do any type of monitoring to a customer's network, obviously you're going to want to do it over time. Initially, if you're just going to test the customer's connection, that's just a quick and dirty way. It is not the only way, and it's not the best way, but that is onboarding a customer. That's the first thing I'll do. And I've only had, honestly, recently, in the past, I'd say 10 years, I've only had to tell 2 customers that don't get VoIP from me or anyone. You got to get a better internet connection before you decide to go with VoIP. So I guess just, again, cover all your bases and just set expectations for the customer, be honest. I know everybody wants to get sales, but don't push a product that won't work for a customer. So that's all I'm going to say about that.
Yeah, I mean, that's a good point. Manage expectations ahead of time, right? That way you don't have to apologize for anything. So many hands. I'm going to go this guy over here.
For latency and jitter, what numbers would you strive to be under for a complete network?
As low as possible. But I'm sorry. The question was, what are the thresholds for like latency and jitter? Which is a great question, by the way. So as humans, we can start hearing latency after around 200 milliseconds. Let's say a quarter of a second, because the time it takes for my voice to get to you It already left my voice. I'm already waiting for a response from you. You don't get it for a quarter second later. So I start talking again, thinking, oh, he has nothing to say. And then he starts talking because he just heard the voice I sent out to him a quarter second ago. So a quarter second, 200 milliseconds, anywhere above there is anywhere above there is danger zone. Obviously, lower is better, but I'd say 200 is don't even bother.
Yeah.
150 is already like a little bit walking the line. You know, you really got to push it. But I do have customers overseas, and just because of where they are, they can only get that good. You know, for jitter, you really don't want any jitter. And if you have any jitter, obviously use a jitter buffer. A jitter buffer is good up to about, I'd say 50 milliseconds. And by the way, for anybody that doesn't know what jitter is, it's the time between each packet. It doesn't only apply to VoIP, but you will hear it the most in VoIP. And sounds like.
So jitter is like variance and latency of packets,
Yes.
right?
It's just the time difference between each packet.
Yeah.
You
And I
know?
mean, if you think about it, like round trip time from here, like if I did a ping to Dallas and it looped back and came back through another carrier, I mean, you're looking at what, 25, 30 milliseconds? That's not bad.
Networks have gotten really good over the past couple of years. I'm seeing some really good response times. But for jitter, yeah, you want to keep it as low as possible. And remember, the more jitter buffer you use on your endpoints, the more delay you're introducing. So try to keep that down. But acceptable, I'd say nothing more than at most that I would feel comfortable is 25, 30 milliseconds. That's already bad. But again, you would use a really big jitter buffer for that. And that has its trade-offs as well. So there we go, 150 on latency, and let's say 20 to 30 on jitter.
This guy right here.
What's my...
What do you think
No,
about
that's not me.
SD-WAN?
I'm heavily into SD-WAN for several projects. Depends on the application, but it is, people throw around SD-WAN as the latest buzzword. So you want to know what problem you're trying to solve with SD-WAN. You know, I have customers that are doing LTE and they're using SD-WAN to solve that. I have customers that they think SD-WAN solves their issue when it's actually MPLS and VPLS that solve their issue. So the things we're using SD-WAN for is actual failover, where you can have two connections coming in, you can totally pull one connection, and like on a VoIP call, you'll get like a split second of jitter, but because it's living on the SD-WAN box, the connection doesn't drop. Then you have deep packet inspection with some SD-WAN products that you can actually classify Netflix traffic. You can actually classify YouTube traffic. And then you have some compression algorithms with SD-WAN. One of the coolest things I saw recently was 2 3 meg LTE connections on this box, and they did a speedtest.net speed test, and it tested out at 50 megs. Now, obviously, you can't compress video, but I mean, this was pretty cool. So to me, it all goes, what problem am I trying to solve, or what problem is the SD-WAN vendor presenting that they can solve? If they're just saying we're SD-WAN and, you know, Cisco, I hate when Cisco does that. It's just a bunch of buzzwords.
Yeah, like Justin said, everybody's got sort of a different spin on it, what SD-WAN is. I've seen some people do SD-WAN and they have a node in a data center, and then they'll get multiple cheap internet connections out at their branch sites, right? And they'll just create a tunnel back in. And I've seen some stuff where I don't know if it's actually in production on anybody's equipment yet, but it was super brilliant. So you just get as many cheap internet connections as you can, and it does almost its version of RAID across all of those links, and it's transmitting enough information that if there's failure along the way, it'll rebuild at the far end. So it can actually do a lot of aggregation and fault tolerance in those networks, which was pretty bananas.
One of the things that I hope somebody a whole lot smarter than me is going to use SD-WAN for is a routing protocol that takes wireless into effect. So imagine if you have a wireless link and SD-WAN says, hey, this wireless link isn't down, but it's the slower of the two paths I can choose, and it can automatically take your routing protocol and account for that. I foresee that as a very real solution of an SD-WAN product, because it knows endpoint to endpoint, and it knows, hey, this wireless link may be 600 megs of capacity, and this wireless link may be 300 megs of capacity. And when I factor in all this stuff, I'm going to choose maybe the 600 meg one, but I may be choosing the 300 meg one because maybe the 600 meg, it can do the capacity, but it's introducing more jitter. And I foresee that. I hope someone takes that and runs with it.
All right. I guess that's done with our opinions on SD-WAN. T-Bone.
One question. All right. I've long held a belief, and please correct me if I'm wrong, that a lot of providers that don't understand Voip are under the impression that actually takes a lot more throughput or capacity, when I've always believed it to be Voip is less a question of capacity and more a question of latency. That it actually doesn't need as much bandwidth as providers think it does. So in your experience, I guess this would be very based on the vendor and manufacturer of the of the service. How much overhead should you really account for one or more VoIP calls happening at a time?
Yeah, it's a good question. It is a misconception that, sorry, to repeat the question, he wanted to know how much bandwidth do you need for VoIP, right? Or how do you size a link for VoIP? Is that about right?
Yep.
Cool. So it's interesting. Well, and two answers to that question. First, how many concurrent calls will you ever be on? Because VoIP isn't really doing much. RTP is really what you care about. That's the voice part of a VoIP connection. The SIP part is the signaling part. That tells the phone and the server what to do and when to ring and when to transfer, all that stuff. But really, you want to know how many concurrent calls could you ever be on at the most. So what I do is just I overestimate. I say, okay, we have, let's say, 10 phones. And if I'm using the fattest codec of, let's say, G711 ULAW, which is like 88K, do the math. It's like 10 concurrent calls, let's say, multiplied by 88K. So you really don't need much bandwidth. You need less than a meg.
What codec do you normally use?
I used to use ULAW, but now G722 and GSM, they're a lot smaller. But I just let the server pick whichever codec it wants.
What's an average size of those?
Well, GSM is going to be like 15, 16K. And then obviously ULAW is the fattest. ULAW ALAW is the fattest. That'll be 88K. And pretty much, yeah, so size it up that way. I'd say pick the fattest code. I just round it up to 100 so that the math is really easy. 10 foes.
But even if like a business has 10 phone lines in there, I mean, what are the odds they're all going to be on a call simultaneously, right?
Doesn't hurt to overestimate. The truth is, VoIP uses such little bandwidth. It's so little. Like, people always think, oh, we need to increase our internet connection. And funny enough, some ISPs, like the big boys that are national, they'll say, oh, what are you going to be doing with your internet when you're going to go buy internet from them? First thing they ask is, how many computers? Are you going to be watching TV? Are you going to be doing VoIP? And right away, oh, yeah, you need more bandwidth. And that really isn't always the case. It won't hurt to have more bandwidth, because chances are you'll never max it out, which means that if you're not doing any prioritization, it won't matter because you've never maxed out your bandwidth. So I'd say that's just how you add it up.
And when he's talking about prioritization, also you can say VoIP is guaranteed this much, but if it doesn't need it, it'll give it to everything else, right? So it never hurts to overestimate in those scenarios.
Yeah, and I'm going to be giving a presentation tomorrow on traffic shaping, so you can see how that prioritization and queuing works and how to guarantee bandwidth to certain applications.
He's not nervous at all for that presentation.
I'm terrified.
Cool. I think maybe we have time for one more. We're bumping up probably on the end. Any more hands? This guy over here, first hand up.
We recommend if we want to resell VoIP ourselves, we recommend us have our own server on SIP server.
Very easy.
Did you pay this guy?
Yeah, exactly.
To ask this question? Repeat the question.
He asked, what would an ISP do to resell VoIP or to get VoIPs, anything of that nature? I'd say just hire me. No, really.
But bunch.
No, really. Obviously, there's so many factors when choosing which provider to go with. Obviously, go for the one that makes financial sense for you. And I would say just make sure you have a good link to them. Make sure it has the features that your customer would be needing. That's not so much a technical question, but more of is your network ready? Is your network ready for it, and does it make financial sense to you? And oh, you mean hosted versus local? Yeah. When you say ATA, do you mean like a PBX or? Okay, so, well, having a PBX on site is always, it'll alleviate certain problems, but if you're doing SIP trunking out your internet connection, then you're back to the original scenario where it's still VoIP going out your internet. But your question about which one to go with, or what was the other? That's really going to be a matter of preference. Okay, first of all, will you be able to manage the PBX? If there's a problem, what will you do? Is your PBX multi-tenant? Are you prepared to go with compliance for reselling VoIP? And that's very expensive. And you have to do some heavy reporting. So is it worth the headache? Is it going to make you enough money where it's worth it to actually go ahead and provide that service? Or do you just want to, give it to another company, maybe white label it? I know there's a vendor here today that's doing VoIP white labeling, and they take care of the billing and the compliance and everything, and they just give you a cut. So you have to decide which one's going to be financially right for you.
Yeah. As I say, not all network guys are server guys, right? And then, so do you really want to have to deal with that? You want to have to maintain all that stuff and worry about the failure, and if something goes wrong, do you have anybody else that knows how to do any of that stuff inside, or is it on you? Because a lot of times it's on you, and it's just.
But I do believe there is some sort of a law that ISPs, if they offer VoIP, they get more government funding for something. Yeah, here, why don't you talk about it? So that's why Wisps are trying to do that. But here.
And what scares me is the 911 stuff. Having.
Yeah,
well, it scares me from a paperwork perspective, because if I fall behind on it or if I don't do my part.
Well, I've heard some folks saying that they put a caveat whenever they're selling somebody a phone that it's not used for 911, right? This is only really for just kind of making occasional calls and stuff like that. Yeah.
You can't. I had a client get sued, and it was not pretty.
Woof. Well,
what you have to do is here. For E911, what you really have to do is just have it in your terms and conditions that the customer is responsible to update their E911 address and give them access to a portal and a way to do that. That will clear you of any liabilities. I know that some carriers, if you dial 911 and it doesn't have a physical address associated to it, maybe because the customer didn't set it up or you didn't set it up for them, you get transferred to some like national central like answering service, and it asks you, what is it called? There you go. Yeah, they charge you pretty heavily. They charge you pretty heavily if you don't do that. So yeah, just set up E911, have the customer, do it, and you'll be in the clear. And put it in your terms and conditions, please. So there you go.
All right, cool. I think we're right at probably the safe spot to stop. So let's wrap it up like we normally do. So I'm Greg. If you want to get a hold of me, gregsoul.com. I very occasionally answer emails, and even more very occasionally do blog posts and things like that. Greg at gregsoul.com. Also, if you want to get a hold of us, contact us at TheBrothersWISP. We also have that Patreon that I mentioned before, patreon.com/TheBrothersWISP. We also have Facebook stuff. Mike updates all that. He's not here. Shout out to you, Mike. So all that stuff comes from him. Yeah, I guess that's the best ways to find a hold of us. If you want to get a hold of me, really the easiest way is to DM me on the Slack. Slide into my DMs anytime you feel. It's really the easiest way. Miller, if somebody wanted to get a hold of you out on the internet, how would they do that?
Well, I like Slack a lot too. But I have a blog, dynstatic.net, and I'm on Facebook.
How you doing? I'm David, and you can get me at david@pennytone.com. Send me an email, drop me a line.
He likes people to call him on the phone.
I get lonely.
Yeah, my usual line is that I'm fairly easy to find. Just Google for my name, Thomas Kernek. I'm all the social networks. Unimus.net is where I live. So that's it. And actually, I have a booth just down there. So if you want to talk to me, you can just find me there.
J2SW.com is, I redesigned it the past couple weeks, has all the stuff I'm into. We have a booth back here for the IX, so feel free to stop by.
Thank you, guys.